Hello dear students, I am Samir Velankar. I welcome all of you to this video on the topic bubble sort. Now bubble sort is one of the most basic sorting techniques, and before we read what's written in black over here, the description of bubble sort, let's understand bubble sort with an example. Suppose we are given an array named as A, and this array has following values. Let's say the values in this array are 10, then comes 5, then there is say 2, then 4, and then -3. Okay, these are the values in this array, and the indexes at which the values are placed are from 0. You know that the array indexing starts from 0 in C, at least in C language, definitely. So this is the array which has 0 to 4 locations. So size of the array n defined over here is 5. The array is of size 5, isn't it? Now what is done to sort this array using bubble sort is we take two counters. Listen carefully. We take two counters I and j. When I say counters, they are simply int variables. Simple int variables and counters, so they can be used in the for loop for counting purpose. And the first counter I is started with n minus 2. Yes, in bubble sort, I always begins with n minus 2. So what is n in our exercise? That is number of elements in the array. Size of the array n is 5, isn't it? So I must begin with 5 minus 2, that is 3. So in our example, the counter I is started with n minus 2, that is 5 minus 2, that is 3. And the other counter j will always begin with 0. Yes, in bubble sort, the first counter I always begins with n minus 2 and the second counter j always begins with 0. Now just check this value of j. Value of j is 0, isn't it? So we simply ask a question on this j as follows. If a of j is greater than a of j plus 1. If this condition is true, then we will swap a of j with a of j plus 1. See, you don't have to do anything extraordinary. Just put the value of j in this question. So as j is 0, this aj means a0, correct? And as j is 0, this aj plus 1 becomes a1. So we are asking, is a0 greater than a1? Check this. Check this in the array. We are comparing, is a0 greater than a1? And you observe a0 is having a value 10, which is greater than the value 5. A0 is greater than a1. Then we will simply swap the values of aj and aj plus 1, that is a0 and a1. So after the swap, 5 and 10 are exchanged. This is what we get. Isn't it so? Now what we do after comparing a0 with a1, we will now check. We will now keep the value of I as 3. We are not going to change the value of 3, but the value of j will become 1. Just check that. So I is kept constant at 3. Remember, I started with n minus 2. I is kept at 3, but j is increased from 0 to 1. And now as j is 1, we will ask the same question. What was that question? If if a of j is greater than a of j plus 1, that means we are going to ask this question for each value of j. And if this is true, then we will swap aj with aj plus 1, writing in short. So what is j now? J is 1. So this question becomes, if a1, correct, is it greater than aj plus 1? That is true. So what we are now doing is we are comparing, is a1 greater than a2? a1 is 10 now. You watch the array. And a2 is 2. So a1 is greater than a2. So we will swap a1 with a2. aj is swapped with aj plus 1. Hence 2 and 10 get swapped. And this is the condition that we are now having. Okay, now by this time you might have understood that we are simply going to keep the value of j as 3. We are not going to change it, but we are going to increase j. That means j is going to become 2 now. It will increase. And what are we going to do with j? Just put it in the question. What was the question? I've erased it due to lack of space. But the question was, if aj greater than aj plus 1, isn't it? That means, is a2 greater than a3? Now you watch. A2 A2 is greater than A3 because A2 is 10 and A3 is 4. So swap will be done. A2 is swapped with A3. So 4 and 10 get swapped. What next? We will keep I as 3. We will not change it, but we will change J. J will become 3 and we will again put this value of J in the question. If is A3 greater than A4, is AJ greater than AJ plus 1? And as you can see, A3 is 10 and A4 is minus 3. So A3 is greater than A4. Hence, we will swap A3 and A4. So minus 3 and 10 are swapped. Now starts something interesting, you watch. Are you going to make I as 3 and J as 4? Are you going to go for this combination? No, this will be senseless. Why really? Just check that if you make J as 4, then you will be generating a question if A4 greater than A5 because you are comparing AJ with AJ plus 1. But how can you compare A4 with A5? Tell me. A5 element is not there. Hello, the array is ending at fourth location. So it is completely invalid to ask is A4 greater than A5. In fact, we have reached the end or the boundary of the array. Hence, we should stop J at 3. Are you understanding? We should not make J as 4. Then what shall we do? I'm just making some room here, okay, so that I can draw this table properly. Fine. So what I will do is I'll just write these array elements over here. Just give me some time. The array elements now are 5, 2, 4, minus 3, and 10. All right. Okay. So what we say, these are the latest array elements that we are having, isn't it? These array elements. Now we say that one pass is over. Check the word pass, PASS. One pass is over because don't you see that we had passed the array, complete pass was done, and we have checked is A0 greater than A1, is A1 greater than A2, is A2 greater than A3, and is A3 greater than A4. Whenever it was true, we swapped the corresponding values which were getting compared. Correct? Now what happens next? Now we will make I, which was always 3. You observe I was 3 all the way over here, isn't it? Now I will be reduced and I will become 2. Just check that. You recall I started with n minus 2 in the first pass, that is 5 minus 2, that is 3, and we kept I as 3 always in that pass. But now a new pass is beginning and I is reduced from 3, it is reduced by 1, so it becomes 2, and the other counter j always begins with 0. You watch out that in any pass, whenever you start a pass, j always begins with 0. And what are you supposed to do with j? Simple, put it in the question. The question asked again is A0 greater than A1? Is AJ greater than A1? And AJ is greater than A1. You watch, A0 is greater than A1, 5 greater than 2. So we are going to swap 2 and 5 again. So these are the elements at the respective places. Then we will keep I as 2. Remember, I remains constant now, but j increases. J becomes 1. Now again ask, is A1 greater than A2? Is AJ greater than AJ plus 1? Just check. A1 greater than A2 is also true. 5 greater than 4 is true. So we will swap 4 and 5. Okay. Now what next? We will keep I as 2, but we will make j as 2. J increases, isn't it? And as j is 2, we will be comparing A2 with A3, AJ with AJ plus 1. So when we compare A2 with A3, 5 greater than minus 3 is true. So minus 3 and 5 will get swapped. All right. Minus 3 and 5. Now something interesting. You see, I'm going to purposely take a pause here and you just try to answer the question while watching the video. Are we going to make I as 2 and j as 3? That means, are we going to make j as 3 means, are we going to check if A3 is greater than A4, AJ greater than AJ plus 1, isn't it? Are we going to do this? Yeah, I have purposely taken a pause here. Okay. No, we are not going to go do this. We are going to stop here at 2 2. At this combination, we are going to stop. This is senseless because asking is A3 greater than A4 is useless. You tell me how can be A3 greater than A4? Watch this. Can A3 be greater than A4? No, because in pass number 1, you might have observed, although I did not tell you, you might have observed that the largest value of the array has settled down. You see, what was the significance of this pass 1? At the end of pass 1, we are sure that the largest value is at the last place of the array. Then what is the point in asking is A3 greater than A4? Anyway, it is going to be false, isn't it? That means we are going to stop this pass at when j becomes 2. Are you understanding? Something more interesting you watch. One more pass is over, we say. One more pass is over, pass 2. But what is your comment on this third element, second last element? At the end of pass 2, the second last element is the second largest in the array. That means after two passes, last two elements are surely the largest elements. Yes or not? Correct? Now, let's see what happens in the next pass. I'm writing pass 3 below here, pass 3. Now we are going to make I as 1. Notice I was 2 always in this pass, isn't it? It remained 2. But now we will reduce I by 1. So I will be 1 and j will always start from 0. In any pass, j begins with 0. And you know what to do with j. Compare aj with aj plus 1. So a0 is compared with a1. Now when a0 is compared with a1, notice 2 greater than 4 is false. So we will not exchange a0 with a1. Okay, they are already in order, isn't it? Then we will keep I as 1, keep I constant, but increase j. Increase j. So j becomes 1. Now we will check, is a1 greater than a2? Is a1 greater than a2? Really? Yes, 4 is greater than minus 3. So we will swap minus 3 and 4. Minus 3 is swapped with 4. And now something interesting again. We will stop our pass here. We will not make j equal to 2, because if we make j equal to 2, then we will be asking, is a2 greater than a3? Come on, how can be a2 greater than a3? In fact, a3 and a4 are the two largest elements. 5 and 10 are the two largest elements. Then it is senseless to ask. It is a waste of time to ask, is a2 greater than a3? Hence, we will stop the pass at j equal to 1. One more pass is over, you watch. So what is your conclusion about second element now? That is, last three elements, when three passes are over, are surely the three largest elements, 4, 5 and 10. Yes, everyone? Now, next pass begins. Let's say pass 4. Pass 4 begins. That means I will become 0, I will reduce, correct? And j will always begin with 0. And as j is 0 here, we will be checking, is a0 greater than a1? And notice in the array up there, a0 is greater than a1, 2 is greater than minus 3. So minus 3 and 2 are swapped. And definitely I don't have to explain, we will end the pass here, isn't it? We will end the pass because there is no sense in making j as 1. You will be then checking, is a1 greater than a2? But a2, a3, a4 are the three largest elements. By the way, now there is no sense in making I as minus 1. All passes are over, and check this array drawn up there. This is sorted in increasing order. So how many passes are needed if you have 5 elements? Yes, 0 to 4, isn't it? 5 elements. 4 passes, pass 1, pass 2, pass 3, pass 4. 4 passes. Then in general, how many passes will be needed if you have n elements? N minus 1 passes, correct? So bubble sort requires n minus 1 passes to sort array of size n. Now let us see the algorithm. What kind of algorithm we are going to write? Trust me, just in 3-4 minutes we will discuss this algorithm. It is so easy. The algorithm is just a byproduct of the table that we have drawn here. If you have understood this table, if you have understood the working of bubble sort on paper, then obviously you understand the algorithm. You tell me, there is a counter I, correct or not? For I beginning with, yes, n minus 2. In our example, n was 5, so it begins with 3 and it goes down to 0. You see, down to means I will have a reverse loop. That means in C language, I am going to write this as for I is equal to n minus 2, correct? I greater than or equal to 0, right? Correct? And I minus minus, because this is a down to loop. Okay? Yes. Okay, fine. So first for loop you have understood. Then what about the second for loop? Inner for loop J. J always begins with 0. You know that, isn't it? J begins with 0 and goes up to I. Notice, when I is 3, notice here, when I is 3, J began with 0 and went up to 3. That is up to I. Then when I is 2 here, notice this, when I is 2, J started with 0 and went up to 2. In any pass you notice, J begins with 0 and goes up to I. So J goes from 0 to I. Correct? And what do you do with J? You just ask if AJ is greater than AJ plus 1, then we swap AJ and AJ plus 1. I have not written that swap as 3 lines. T is equal to AJ, AJ is equal to AJ plus 1, and AJ plus 1 is equal to T. This is an algorithm, and it is expected that the reader of the algorithm knows how to swap AJ and AJ plus 1. So this is how the bubble sort algorithm can be seen. I'm just clearing the slate here. Just see, the description of bubble sort has been given up there, that it takes n minus 1 passes. You can pause the video and see I goes from n minus 2 down to 0, j goes from 0 to I, and for each value of j this comparison is done. If it is true, then we swap aj and aj plus 1. That's bubble sort, isn't it? Now before we leave this discussion, just check that bubble sort always performs in big O of n square. That is, time complexity of bubble sort is big O of n square. Now why really? Just check, it is so easy to prove. Suppose we have n equal to 5. Size of the array is 5. Imagine, just as we took earlier. I am not even drawing the array now, okay? But size of the array is 5. Then what was the counter I and j we got? What were these values? I began with 3, j with 0, then 3 1, 3 2, 3 3. Correct? This was pass 1, you recall? Then we had pass 2, in which I reduced to 2, but j was 0, then j was 1, and then j was 2. Then ij again. I began with 1. I now became 1. I reduces, isn't it? It was 2, now it becomes 1. And j is 0, and then j is 1. And the last pass had I and j as 0 0. Now tell me, isn't for every value of j, for each j, we are checking if aj is greater than aj plus 1. So this comparison is getting done for each value of j, isn't it? For each value of j. So how many times is this comparison getting done? The number of times this comparison is getting done will be counted by us now. Just check. Have patience. Just check. You want to know what is time taken by bubble sort, correct? You want finding time complexity of bubble sort. Then you just have to count how many comparisons are done, because comparison is most important operation in bubble sort. So we don't count how many repetitions does swap does, because swap is a result of comparison. Just tell me one thing, is it compulsory that you always swap whenever you compare? Just think over it. I mean, if you compare two things, will you always swap them? No, it depends, isn't it? It depends on the comparison. If aj is greater than aj plus 1 is true, only then you will swap, otherwise you won't. That means how can you count number of swaps? Come on, it is so uncertain, but definitely certain. The thing which will definitely be done is comparison. Then we will count the number of comparisons. And the number of comparisons is so easy to count. In pass 1, number of comparisons done were 4. 1, 2, 3, 4. Okay, 4 comparisons. In pass number 2, number of comparisons done were 1, 2, 3. Okay, 3 comparisons. In pass 3, number of comparisons done were 1, 2. Okay, 2 comparisons. And in pass 4, last n minus 1th pass, isn't it? Last pass, 1 comparison was done. So 4 plus 3 plus 2 plus 1 comparisons. This is when n is 5, size of the array is 5. Then so many comparisons were done. So in general, for any given value of n, the number of comparisons is n minus 1 plus n minus 2 plus up to 1. Just check this. For n equal to 5, this was 4, isn't it? N minus 1, then n minus 2, up to 1. So in general, for any given value of n, the number of comparisons are n minus 1 plus n minus 2 up to 1. Now, I guess you know that this is an arithmetic progression, isn't it? How many comparisons is bubble sort doing? The number of comparisons bubble sort is doing is n minus 1 plus n minus 2 plus this goes on plus 3 plus 2 plus 1. Now this is an arithmetic progression. The series sum can be taken as n into n minus 1 by 2. This is the number of comparisons. For example, when n was 5, we got 4 plus 3 plus 2 plus 1. Observe, this amounts to 10 comparisons. This is exactly n is 5 into 4 upon 2, which is 10. So our formalization is correct. These are the number of comparisons. If we expand this, we get n square by 2 minus n by 2. So many comparisons are done by bubble sort. But then when we have to now write big O notation, the big O notation takes only the biggest degree of this polynomial. This is a polynomial, and we drop all the lower terms, even the denominator 2 here and n by 2, all these terms, and we write n square is the time complexity of bubble sort. That means bubble sort works in the order of n square. That means bubble sort will do maximum n square comparisons. Please try to understand, this should not be read as bubble sort takes n square time. Wrong. This n square written over here is number of comparisons done by bubble sort, and we say in the worst thing, highest number of comparisons bubble sort will do is n square. Actually, it is not even n square. It is n square by 2 minus n by 2, isn't it? But then we have written big O notation. Remember, big O notation means if n square by 2 minus n by 2 is the actual number of comparisons, then this is always less than n square. That's the meaning of big O notation, isn't it? So we got a polynomial n square by 2 minus n by 2, and we say n square by 2 minus n by 2 will be always less than n square, isn't it? So we can say Tn, time taken to sort n elements, works in the order of n square. I hope you have understood a time complexity of bubble sort. When we return in the next video, we will see another interesting sorting technique called selection sort. Thank you very much.